Hey guys, in today's video, we are going to be talking about characteristics of quadratic functions. And we will be able to describe the characteristics and find other information, whether we are given a table of values, a graph, or an equation. So in different problems, you're going to be given different information and then use the given information to find the rest of what you need to know. So here's our first example. And in this first example here, the information we are given is the graph, okay? So you can look down here and you can see that we've been given the graph. That is the information we're going to use to find the information for the whole rest of this chart here. So the way I like to start if I'm given a graph or if I'm giving a table of values, I like to start with factored form. Now, if you remember when we talked about factoring and solving with factoring, we talked about how you are going to have two binomials multiply to 0, okay? And we talked about how the purpose of factoring was so that you could find the solutions really easily, because if either of these two factors, right, if either this factor or this factor is 0, then the entire equation is going to be 0. Okay. Now, I have a graph, so I can actually see where my zeros are. So I know that I have two zeros, and those zeros occur here and here. My zeros occur where x is equal to 1 and where x is equal to 3. Okay, so some people might be tempted right away to think, okay, so if my zeros are at positive 1 and positive 3, then in factored form, I should have x plus 1 and x plus 3. But I want to be careful, and I want to remind you guys that we have zeros when x is equal to 1 or when x is equal to 3. So think about what happens if I have the 1 here, right, in place of x, or the 3 here. Okay, what would I have to put after a 1 to make it 0? Well, I would have to subtract 1, right? 1 minus 1 is 0. So it's not actually a positive 1 that I put up here. I actually put minus 1. Because if I put x minus 1, when I plug this 1 back in for the x, that is when that whole term goes to 0. Okay, and then same thing with the second set of parentheses. If my 0 is at 3, well, in order to get 0, you would have to do 3 minus 3. So that means that if my x value is 3, I'm going to have a factor of x minus 3. Okay, and then you can see looking back here at factored form, okay, if I were to plug in either of my zeros, 1 or 3, that whole entire expression on the right side would come to 0, making this a true statement. Okay, the only other thing that we have to do is an equation. When we talk about the equation of a graph, you don't have a 0 on one side. You have y and x's. So this part over here where I said 0, that is actually going to be y. So I'm going to change it to a y. And the reason I can do that is because this is the equation of the graph, right? So at the values x equals 1 and x equals 3, that y is 0, but it's not always going to be 0, right? When x is 4 or 5 or 6, right, it's not all going to come out to 0. It's going to come out to some other value, which is why there are multiple values on the graph. So my final equation is y equals x minus 1 times x minus 3. One other thing I will point out is that sometimes you have to go one step further. You have to check to see whether this is a positive or negative quadratic. So you can see here how we have this curve of this graph is facing up. It sort of looks like a smiley face. It's going up. If that is the case, then this is positive, so I don't have to do anything. Let's say you were given a graph like this that's facing down, right? It's sort of like a frowny face. That means that my function is negative, and I would just have to put in a negative right in the front. So my equation would be y equals negative, and then whatever else I found. Okay. But again, in this case, we don't have to worry about that because my graph is positive. So there's the equation. Okay. Now, once we have found factored form, I guess we can fill in the chart next. It doesn't really matter if you fill in the chart if you find standard form next. You could do them in either order. They're not really dependent on each other, but I'm just going to fill in the chart because that comes first on this slide. So you see a chart, and it gives a bunch of x values. So negative 1, 0, 1, 2, 3, and 4. And then it is asking for y values. So basically all it's doing is it's saying, okay, where x is -1, what is the y value? What is the coordinate where x is equal to -1? Now, most of these we're actually going to be able to find on the graph, so I'm going to start with those. So let's see if we can find where x is -1 on the graph, right? That would happen right here. Now, as I sort of look up from there, I can see like along here, the function doesn't actually reach there on the part of the graph we can see, so I can't determine that graphically, so I'm actually going to hold off for a second, okay, and just move to the next part. So the next x value is 0, so that's right here, and you can see if I trace up from there, I have a point right here, and since that point is at 3, that's the y value, right? My point is 0, 3. I'm just going to fill in 3 as the y value. Okay, and then I'm going to keep doing that as I moved over, right? So where x is 1 is right here, and you can see that the y value there is 0. Where x is 2 right here, I see that my y value is down at -1. Where x is 3 right here, we see my value is 0 again. And where x is 4, it looks like, oh, I'm back up at 3. Okay. And you can see how quadratics are symmetric functions, meaning that the same thing happens on both sides of this vertex, right? The vertex being right here, that sort of center point. So you notice that this right here, it's symmetric. It reflects basically. So it's like 3, 0, -1, -1, 0, 3. Same thing's happening on either side of that -1. Now, we have to go back and find the very last value that we weren't able to find on the graph. If you were asked to find a point and you can't see it on the graph, what you're going to do is you're actually going to go back to the equation and plug in this x value. So, I want to know what the value of the function is at -1. So what is f of -1? In other words, the value of this function when x is -1. So I'm just going to plug -1 in. Okay, I replaced my x's with -1s, and then I'm just going to simplify. -1 minus 1 is -2, -1 minus 3 is -4, and -2 times -4 gives me 8. And so my y value is 8. And that is basically it for the chart. The next thing we're going to do is find the standard form of the equation, so I'm actually going to have to erase some of this work to give us space. The standard form of a quadratic, remember, is written in the form y equals ax squared plus b squared plus c. So there's no parentheses or anything. So basically, in order to find the standard form of the equation, what I'm going to do is actually multiply out these two binomials right here and see what it simplifies to. And when I say I'm going to multiply those out, we've practiced a lot with binomial multiplication at this point. So that's going to be my double distribution. So I'm going to start by distributing x. Right? So x times x gives me x squared. X times -3 gives me -3x. Okay? And then I can go in here and I can also distribute the -1. Remember to distribute the negative. That gives me -1x and +3. Okay? And then if I combine those two like terms that I see here in the middle, -3 minus 1 is -4, so that gives me x squared minus 4x plus 3. And that is the standard form. So I wrote it over here just to kind of save space, but that basically goes over there. That was the worst error I've ever drawn. Right? But that is the standard form of this equation. The next thing I'm going to do is I'm going to find the different properties of this equation. So the first thing we're asked for is a line of symmetry. And we haven't talked about that a lot in this class yet. Symmetry is something we would have talked about more last year in geometry. But basically, the line of symmetry just means the place that's in the center of the graph where both sides would be a reflection or a mirror image. So you see how on both sides of this graph, on one side, it's sort of curving down like this, and on the other side, it is curving up like that. But if you were to fold it across this dotted line in the middle, right, you can see how the right side would kind of fold onto the left side. And so that makes this the line of symmetry. Now, the line of symmetry will always go through the vertex, okay, which is either the highest point or the lowest point, right? So like if your function is facing this direction, there is a minimum right there. Whereas if your function were to face this way, your vertex would be at the top. But basically, your vertex is just sort of like that point where the function ends on one side. So I'm going to write the equation of that dotted line I just drew in. Remember that the equation of a vertical line, it always is in the form x equals some number. Okay? That is because at any point on that vertical line, x will always be 2, right? As I move up, x will be 2. As I move down from here, x will always remain 2. But because we're moving up and down, y changes. So the only thing that's constant is the x. And the x that entire time is 2. So that means that this vertical line has the equation of x equals 2. Okay. The next thing that I'm asked for, and I'm going to clear this graph up a little bit for us, is the vertex. So again, I mentioned the vertex is either that minimum or that maximum. So it's basically that point in the very center of my function. So in this case, my vertex is down here at 2, -1. So I'm going to put that coordinate in there. And then I'm also asked whether this is a maximum or a minimum. So basically, a maximum means the highest number on the graph. So it's going to be the top point. So it would be way up at the top of the graph. You can see this graph doesn't have a maximum because if you look at these two places, it sort of extends off the graph. And I actually extend to infinity in the positive direction. So there's no real like finite maximum. But you can see that this point, this vertex, is at the bottom of the graph. So that is a minimum, right? It's the absolute lowest value this function ever becomes. Now it is time for x-intercepts and y-intercepts. So x-intercepts are where my function crosses the x-axis. So I'm literally just going to draw in a dot at the two places where it intersects the x-axis. And it looks like the first one, the one on the left, we see an x value of 1. And because we're on the x-axis, my y value is 0. And then my other one, it looks like my x value is 3. And again, my y value is 0 because I'm right on the x-axis. Looking further at y-intercepts, the y-intercept is the place where I cross the y-axis. So that point is right here. Okay, and so my x is 0 there, right? I haven't gone right or left from the center, but I'm up 3. So the y-intercept is at 0, 3. Next, we're going to talk about domain and range. So always remember that domain is your x values and range is your y values. And it's just asking over what values does this function cover. So remember that if my graph is just sort of going off the page, that means that it continues. So there's essentially arrows going to the upper left and upper right of this graph. So domain is asking what x value my function covers. Remember, I'm looking left to right. What values do I cover? Well, you can see that there's an arrow pointing off slightly to the left of this graph, which means the graph continues forever in that left direction. And there's also this arrow over to the right, meaning my function continues forever towards that direction. So my domain is actually all real numbers, or how we like to say, from -infinity to infinity. Right? My graph starts the whole way to the left and it continues the whole way to the right. We can't see all of that on the actual graph, but because I know the graph continues, that's going to be true. And with all quadratics, you will have the same domain. Your domain will always be -infinity to infinity. The range will change though. Okay? Because the range is our y values. So that means top to bottom, basically what values are covered. Now you'll see this function, the bottom, the minimum we already found was right here. Okay, so that's happening at the y value of -1. So there's nothing happening beneath there, right? There's no function below there. My function starts at -1 and it increases up forever, right? These arrows continue in the positive infinity direction. So my range starts at -1. And because that value is included in the range, it's a bracket, and then it increases all the way to infinity. Okay, and then our last part of this, our last property, is to find the increasing and decreasing intervals. So what I like to do is start at the left side of the graph and just see what's happening. So as I'm at the left side of the graph here, right, the leftmost point, if I trace my function, I see how it's going down. And it goes down, 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 until right there is where it sort of turns and starts going up. So that whole place that I just highlighted, that is the decreasing interval. Okay. After that, it's going to start going up. So these graphs, they do have both increasing and decreasing happening. So we explain over which part is it decreasing and over which part is it increasing. So it starts decreasing at the beginning of the graph, right? As soon as we started. So it started decreasing at negative infinity, right? At the very beginning of the graph. And it kept going until right here where x is 2, right? Remember, we always talk about axis because we're talking about left to right. So from the whole way over here all the way to this point, my function is sort of swooping down. However, after that point, right, we can see how starting here, my function is going up. And it goes up, 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 up for the rest of infinity. Right? So my increasing interval starts at when x is 2, and it continues for infinity. And that's basically this problem. I will point out that for increasing and decreasing intervals, we learned this before, but just remember that you never use brackets because you don't actually know what is happening at exactly this point. You can't say that that is included in the increasing or the decreasing because it's shared in both. It cannot possibly be doing both at that one point. So at that one point, it's just a point, it's just staying still. But right after that point on either side, it's either increasing or decreasing. Okay. Now we're going to do one more problem. I'm going to move through this one a little bit quicker, but in this example, you can see that I'm not actually given the graph, but I am given the standard form of the equation. So from that standard form, I can actually find all this other information. Again, the order you go in doesn't really matter. So I can start in a couple different ways. One way would be starting with writing factored form. One would be to fill in the chart. I guess I'll fill in the chart again just because it's kind of in that top upper left. Basically, last example, I told you to find all the values you could from the graph and for the rest of them plug in. In this case, you don't have a graph. So you're actually going to have to plug all of those x values in. Now, if you have a graphing calculator, you can type this function in the graphing calculator and then go to the table button on your calculator and it will actually find a table. So you can just pick the y values from there. But you can do it in your head as well if you want. So I'm just going to kind of show you an example for the first couple. So if I were to try to plug in -1 here, I would rewrite this equation, but in place of the x, I write -1. So, and I'm going to actually write this further off to the side because that part of my screen is really bad. So I'm going to write it over here instead. But -x². So I replace the x with -1, and then plus 4x. Again, I replace the x with -1. Okay, and if you see that, we can see -1². So this part right here, that turns out to +1. Okay, but there's a negative in front of it, so that leaves me with -1. And then 4 times -1 is -4, so we're left with -5. Again, if you are struggling with operations with negative integers, double check this in your calculator, but this comes out to -5. Okay. I'm also going to show you plugging it in with the value 0. So if you're to plug in 0, we have negative times 0² plus 4 times 0. Well, since both of those terms have a 0, anything times 0 is 0, that whole thing is just going to come out to 0. Moving on to the next problem, if I plug in 1, right, -1² plus 4 times 1, that is equal to -1 plus 4, which comes out to +3. And then we just keep moving like that. I'm not actually going to show all of these because I feel like that is a waste of time. This video is already pretty long. But if I were to plug in 2, that would come out to 4. If I plug in 3, that's going to come out to 3. And if I plug in 4, that's going to come out to 0. Right? And I followed that same process every time. And again, you can sort of look and see how these values are symmetric around this point here. The point they're symmetric around, actually, you already know initially that's going to be your vertex because it's always symmetric around the vertex, so we will keep our eye out for that later. Okay, but it's just always good to know because if it's not symmetric, there's probably an issue somewhere. Okay. So next we're going to write factored form. In order to write this in factored form, we are literally just going to factor the original, okay? If you look here, we have -x² plus 4x. It is not a trinomial, so we're not going to be factoring it as the product of two binomials. we're going to look and see, is there a greatest common factor? Now, you see both terms have an x in it, so we are going to be factoring out an x and then seeing what's left. But if you notice, your leading coefficient is -1, and we've talked about how if the x squared has a negative, you also need to factor that out because we don't want there to be a negative inside the parentheses. So I'm actually factoring out a negative x. When I factor out a negative x, the negative in the negative x squared is gone, and one of those two x's is gone, leaving you with just x. And if I factor out a negative x from positive 4x, well, when I factor out a negative, I'm actually left with a negative because factoring out a negative flips the sign. And then I've taken away the x, but the 4 is left. And that means my factored form is y equals negative x times x minus 4. So from here we can go on and graph a couple different ways that you could graph this. One is that if you see factored form, like let's say you didn't have this table of values, you could use that to graph. That can be an effective way to graph. But if you have the table of values, the easiest way is to just look at all these values and plot the points and then connect them. So I'm just going to go through and plot all these points. So -1, -5, and this graph is unlabeled, so we're just going to have to count. Right? 0, 0, 1, 3, 2. Okay. I think I had erased that because I wrote something on top of it and clearly misread it when I wrote that back, but I think that that was actually supposed to be a 4. And I read that as a -1 because I had circled through the other part, right? I did something like this, and then I was like, oh, look, it's a -1. But it wasn't a -1, it was a 4, so I rewrote that wrong. Whoops. But notice that I found my mistake because I was like, well, it doesn't make sense for this point to be down there. That looks wrong, so I was able to find my mistake. Anyways, I still did the chart correct when I actually did the chart. I just recopied it wrong. So 2, 4, 3, 3, and 4, 0. So at this point, you can see all those points and you can see how they sort of follow a trend. I could even put another point right here because I know that I will continue to be symmetric on both sides. But when it comes to actually drawing the graph, I just go ahead and I connect all these points in order. Okay. You know, it's a sketch. It doesn't have to be perfect. Once you plot the points, I know whatever you sketch is going to be attempting to go through all those points. Okay. And then last but not least, let's move on to the properties. So line of symmetry, we talked about that already. That's going to go through that vertex, right? So the vertex is sort of that middle point. So as I draw, I'm just going to draw up and down straight from that point. Okay. You may not be able to see that super well, but there's that line. Since the x value there at the vertex is 2, it looks like our line of symmetry is going to be x equals 2 again. My vertex here, right, this point right here, because that's sort of that middle point, it is the very, very top of my graph. That is at 2, 4. Okay. And in this case, this is actually a maximum because you'll notice this is a little bit different. This is at the top of that graph. And while we're at it, I just want to go back and point that out again. When we wrote this in factored form, notice how we had that negative out in front. Remember how I told you that if your quadratic is facing down like a frowny, then that's a negative. So there's where the negative comes in. Because we weren't writing the equation this time from scratch, we were just factoring it. Didn't come up earlier, but still think that was important enough to point out. Okay. So next thing, we have x-intercepts. Again, those are the 2 points where I cross the x-axis. So I'm going to color those in there. Those are happening at 0 and 4. So the first one is at 0, 0, and the second one, x value is 4, y value is 0, so that's 4, 0. Okay, and then your y-intercept is actually going to be the same as this x-intercept because look, you cross the x and the y at that point. So 0, 0 is both an x-intercept and a y-intercept. Now I'm switching back colors because that one seems to be hard to read. Okay, now we are talking about domain and range. Again, looking at this function, we have these arrows at the bottom sort of going off down and to the left and down and to the right. That indicates to me my function starts the whole way to the left, it continues the whole way to the right. So my domain is all real numbers or -infinity to infinity. Like I said before, all quadratics have the same domain. Okay. Then we are going to talk about the range, and the range is the y values. So I'm looking bottom to top, what values are not covered as a part of this function. And you'll see that the maximum of my function we talked about was that vertex. My function never gets above 4, right? So my function starts the whole way down here, right? And all the way up to here, right? You see how there's parts of the function that sort of cover that entire height, but there is nothing like up here, right? You see how that's all like empty space? So that is not a part of the function. So since my function only goes up to 4, we say that my function starts from negative infinity and goes to positive 4. And again, because that is included, I make it a bracket. Right? The other thing I want to point out here, some people, what you might see first is that the maximum is 4. Remember that you always go from bottom to top or from, again, smallest to biggest. So negative infinity to 4. At this point, I've like really kind of made this graph sloppy, so I apologize. I'll try to erase some of this unnecessary information. And we are going to talk about the increasing and decreasing interval. Again, I just like to start from the far left and sort of see what is happening. So at the furthest left point down here, if I start increasing, well, or if I start tracing my graph, I'm increasing, increasing, increasing. So from the beginning until there, I have my increasing interval. So I start increasing at the beginning of the graph, right? The left of the graph is negative infinity, and I keep increasing until I get to 2. Now 2 is where my vertex is, and so that is the turning point. And starting after that, right, oh, that's not what I meant to do. Oops, I want to highlight. Okay. Starting there, right, you see how we go down from there. Right, and so starting at that point 2 and going until infinity, we are decreasing. Okay, so those are our 2 examples we're going to go over. As always, if you have any questions, let me know. We can talk about it, but hopefully that was helpful, and I will see you next time.